go, here we 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 go. Here we go, here we go, here we go, here we go. Hello and welcome.
Hey.
Thanks for coming today. Hi in the chat. Glad to have you here and excited today to talk about the Datadog container report that's came out at the end of last year. But we wanted to, I really wanted to go over it because I love these reports yearly that kind of like just show the state of how things have been growing and just in general where the industry is kind of headed and some pitfalls of, hey, we've learned some things in the last year. Here's some things that you may want to check out. So excited today to have Alon join us. Go ahead and do a little intro.
Hey, thanks for having me. I'm Alon Rabinovich, the VP Product and Community at Datadog, and so I've been known Justin for many years from the open source community around the LA area, but very, very excited to finally be on the show.
And, you know, I have to say, I look at this is like the state of the union. I really look at this report every year. I always look forward to it because I think, you know, Datadog, you folks are just everywhere, right? I mean, you're like the, I don't know, the Coca-Cola of monitoring now. You know, it's just when you talk about how are you monitoring your containers, your environments, Datadog is just so common, you know, so it's really cool to see that you're taking this data and you're kind of telling us, hey, here's how people are using containers this year.
Yeah, and we try to do this for a couple, you know, for a number of different technologies. Container was the first one we did it for, starting back in I think 2015 when Docker was still just starting to get adopted everywhere. We started off with a Docker adoption report, and over the years we've sort of broadened it to be more than just Docker, to look at other types of containers, to look at orchestrators, to look at other things. We've also done a state of serverless report, which is also pretty relevant to the AWS audience, and so we have visibility into all these different ways in which our customers are running and using these technologies. And so if we can aggregate it in like a highly anonymized way and try to find industry trends, I think that's beneficial to everybody. I mean, it's beneficial to me as a product manager because it lets me know that, like, well, containers are really cool and they're getting a lot of adoption. It's not just people at conferences and meetups. I should spend time building features for these users. And then similarly, I think it's helpful to our customers because they're looking just for validation of the patterns they're picking up. Like, our service mesh is ready yet? Am I the only one not using it yet? What are the technologies people are using? What are the practices that they're following? And so if we're able to show that stuff, I think it's helpful to everybody. So.
Yeah, and just to call out for anyone, watching the stream right now, like, Alon is from Datadog. I have used Datadog in the past as a customer. They have the softest shirts in tech. So if you don't have a Datadog shirt, I would recommend getting one. But it's also like, we're not necessarily like the learnings from this report aren't only for Datadog customers. This isn't hey, if you use Datadog, go check out this report and you'll learn something on how to use Datadog better. It's like, no, you can use Datadog better by doing some of the stuff, but this is a very generic container report where it can apply to everyone. So we want to walk through a couple of the things that we talk about here, but also I have a quick demo on how to kind of like benefit from what we're seeing, what Datadog's seeing and what the industry's seeing with how to use containers successfully and some of the things you might want to consider. So really, if you're here just like, oh, well, I don't use Datadog, so this doesn't apply to me. It's like, well, do you use containers? Because like maybe this does actually apply to you.
Yeah. And just a quick note on the t-shirts. I have many. They're the best shirts ever. I was telling them earlier. Unfortunately, mine have either shrunk or I've grown. Not sure which one it is, but they don't fit right now. Otherwise, I'd be wearing it.
Yeah.
I think my biggest problem with the Datadog shirts is I don't ever have enough, or my wife steals them because they are soft.
They're incredible. They're so soft. So when conferences come back in person, I look forward to my next Datadog shirt. I'm going to go up a size.
It's the motivation too, because you're like, hey, if I can drop a size, then I can fit in all those Datadog shirts, right? Like that's like the diet motivation.
There you go. I like that. Anyways, go on.
So yeah, let me pull up my screen here real fast and just remember how to do this. There it is. And going over a little bit here on just what's in the report in general. Like it's a very buzzwordy sort of title. It was like, hey, there's 11 facts. Like, okay, like this isn't like 11 things to consider, like moving to, containers. This is just like, hey, Datadog has a lot of data. They are a vendor that is neutral in this container space. If you're running containers, you can send stuff to them, and it doesn't matter if you're on-prem, in AWS, on your Raspberry Pi stack. Like, you can still like send your data over here, and they can gather, they provide value. I've gotten much value out of being a customer in the past, but it's really about like, hey, let's anonymize a lot of stuff and just see where the trends are, right, Ilan?
Yep. Exactly. And if you are looking for a log solution or a metric solution or tracing or synthetics or security or any of these other pieces that help you understand your environment end to end, totally happy to help you. The goal with the report here is really just to look at general trends on the industry. These happen to focus on the audience that we're looking at is Datadog users, so there's some selection bias here, but we think it's pretty representative of what's going on everywhere, and so hopefully this is helpful to you, even if you're not a Datadog user today. And if you do want to give it a shot, we have a free tier, no credit card. Go Datadog.com, sign up for a trial, give it a shot. Monitor your Raspberry Pis or your home lab setup, and hopefully eventually your work stuff too. But let's that's for another show.
Isn't there also? I thought there was like a free T-shirt. Like if you sign up for an account, you get a shirt or something like that.
There's always some promo running. I will figure out what those are. We can drop them in the show notes or something later.
Those links are relative right now. Everyone get a large or an extra large, whatever you need.
Yeah.
But and then also, as you mentioned, like this report has been going on for a long time. Like I remember when this was for Datadog marketing. Well, I'm just saying I was a customer and I like their shirts. So
for sure. I mean, the reports have been going on forever, right? When we did the first, I think the first time we put this out it was like containers are actually being used in production, and here's the percentage of people actually who've used it in like more than 90% of their workloads, and you're like, wow, that number is actually pretty high. Today, if I tell you that containers are being adopted, I might as well do a report on why water is wet. And it's like, well, yeah, we all know this. So it's, we have to focus on just different angles, which is not just how many more people are using containers, but how are they using them and what's the patterns that are in there.
Right.
These animations in the headers are always fun too.
I know. I forgot I had to mouse over it to get it to go. And the very beginning of that report, like the thing that I thought was like, okay, here you're looking at 1.5 billion containers. Like this isn't like, hey, right, we had, a couple thousand, we had 1 million. No. There's 1.5 billion containers that were used to kind of gather this data. And it's like, okay, that's a big number. I don't know anybody running 1 billion containers besides like very select gigantic companies. So this is a around the globe, all the customers, any Datadog customer doing this. So.
Right. And exactly. And so if you look at, sort of look at the trends over the years, every report has, we're talking about more, we're usually looking at sort of like the past 12-month period in one of these reports, but, the number of containers we look at every year is obviously increasing. Yeah.
And so going through here, just to, select out a couple things that we want to talk about. Obviously at the very beginning, orchestrators were key, right? Like when we looked at this report, was it 4 or 5 years ago? This was like Docker was a thing. How many people are adopting Docker, and how are they running Docker? Like, what's the OS? Was in a lot of cases like, hey, where are they running Docker? Was it Red Hat? Was it Ubuntu? Was it whatever? And now it's like we've moved up a stack of like, hey, like that OS layer kind of isn't the thing that is like matters for like running at scale. It is about the orchestrators.
Yeah, and I think we're long past the tipping point of. You're not just running your container by yourself, Docker run, or like kicking it off as an individual process. These days, most people are doing this with an orchestrator, and more than half of those are Kubernetes. But we see quite a bit of other orchestrators as well. I think the key question here is who's the other half, and a large chunk of that, if not most of it, is ECS, which we see a ton of adoption of that and Fargate on both of them. So.
Right. And so, yeah, that's interesting because the other big names when you think of container orchestration is you got Nomad, you got Mesos, and you got ECS. And seeing even from this graph, 2017 to 2020. So over the last 3 years, we've grown from less than 20% over to 50% of Kubernetes usage. But there is still that other, like, where is that other 50%? And as you mentioned, like a majority of that other 50% is ECS in Amazon, which is awesome.
Yeah, it's incredible. And I think Fargate has helped drive a lot of that too. And I know I don't want to give away too much because it's in the report. We're going to go touch on it, but Fargate, there's a great stat here about Fargate, which we'll get to. So I'm not going to spoil it, but
pulling in this question from Stars Hold Malice. What's one thing people often overlook when setting up containers at scale? And I don't know about both of you, like from my experience, the biggest thing that like I always had a problem with was actually like focusing on the scale part, like saying like, I need this to be infinitely scalable. I need this to be as big as, some other company. And it's like, no, actually like starting really small and finding the easy applications to just like, let me put this in container. And like, I started container adoption. Like we actually ran VMs and we just went to the machine and did a Docker pull and we opened a port and like that. Okay, let's add that to the load bus. Like we did that manual step. And that was like, for us was a really great way, not only just to be able to like slowly adopt people and get used to it. Like what does debugging look like? How do I package these applications? What does CI/CD look like? But then it was the next stage of like, okay, now how do I gain trust in this system to do all that stuff for me?
Yeah. I mean, I think that, and the other piece is, focus on what the business problem you're trying to solve is. Like we all like our tools. I like to tinker too, but if the tools don't solve a problem, then they're a distraction, right? So like we're not picking up containers to build up our resumes. We're doing it because they make something faster, better, more dynamic, more scalable, more reliable. And so just making sure that you understand what your goal is before you dive into the tech, I think is key.
I love that. I really love what you said there. And, I think both things that what Justin said, what you both said there are so critical. Like don't build, when you go into this, I think people sometimes think, oh, I'm going to need a service mesh. I'm going to need all these really amazing tools that I don't even know if I really need them. I just think I need them. So really understanding the problem you're trying to solve. And I think scale is a big one too, is figuring out what does it take for me to scale this container, this application, and use that and go back after a couple months, look at how you performed, look at the metrics, see what you're doing and tweak. I think it's a continuous process that you're just constantly learning and evolving.
Yeah. And I mean, remember there's things in your organization that are likely predate containers and predate all this Kubernetes fun and predate the cloud things that we're doing in AWS and right. And so those things have to scale as well, right? If you have an unlimited, an infinitely scalable, front end that's running in your Kubernetes environment on EKS and AWS, and like, yay, it auto-scaled because there's more traffic, but then it all hits back like some mainframe back in a data center somewhere that doesn't scale. Well, you haven't solved the problem. You've just pushed the problem elsewhere. So, and that's the thing. All of these systems all of these big organizations have hybrid environments. Like unless you were born in the last 5 years, you're probably not 100% containers or 100% serverless. So.
Amen.
Yeah. Where is that? And this was obviously going to that first point of 90% of all containers you're seeing are orchestrated. So there is that 10% where it's people are either going through that adoption phase of like, let's learn how to do this at a smaller scale, or we don't need orchestration, or we have, my application only can run on one node anyway. So what's the point in having like all this overhead? There is plenty of that.
Yeah. I mean, I think so imagine, you might be triggering these off there's also other types of orchestrators that I think aren't covered here, right? So like you might be kicking off these containers in your CI environment via like a Jenkins job or a GitLab job or something, because containers are huge in those testing cycles in terms of creating these reproducible environments. And so like why, maybe that doesn't need to be scheduled on a Kubernetes cluster or a Mesos cluster or something. Similarly, I think we talked to a lot of folks that, they see containers less as an orchestrated thing and more of like more of a thick package, right? So like they don't package their their app up anymore as an RPM or a WAR or whatever other archive you were using back in the day. They just deploy the container to one, and if it's one container to one host or one container, or just a way to package up the process, like maybe Kubernetes isn't a thing you need. So
that's well said. And I think I love these graphs because you're showing, I was going to ask you, but I see it here is really what the trends that you've seen, so this obviously goes back, to 2018. And frankly, I think containers haven't been mainstream, with Docker for that many years, but as you look back, I guess, what have you seen? What's the biggest change you've seen just over the past few years with these reports and what you've learned?
I mean, I think the orchestration change, which, I think we've talked about, I think we've talked about a few times, has been huge, right? It changes the level of dynamicism in these things. Like if you are just running the container as a package format rather than as a way to schedule your workloads, well then these aren't going away every 30 seconds or every minute. They're there constantly, and so that level of dynamicism has been big. It's been interesting to see there's a lot of the use cases around sidecars and sort of what's picking up there. In terms of technologies, right? It started off with, and what people are using there. So we're starting to see a bunch of Istio, starting to see a bunch of Envoy, but for a long time, people weren't yet ready for those service meshes. And I think even now it's still pretty early on in the curve. Like I don't think we've hit the level of service mesh adoption today as much as we were seeing Docker adoption in 2015, right? So people are still trying to figure out the complexity versus the value that a lot of that offers.
It's also interesting thinking about what those tools are replacing. Like Docker replaced if Docker replaced your RPMs and Istio replaces your switches, replacing the network layer is can have a broader impact on what you're doing. And it's in a lot of cases harder to do. Like I can automate a spec file for an RPM and that's, fine. I don't need the spec file anymore. I'm going to use this Docker file or bash script. But hey, let me change my network layer or my proxies. Sometimes that's a little scarier. Sometimes that's just a little harder to understand what's actually going on.
Yeah. And people put a lot of rules and complexity in those various routing layers throughout their applications. The number of, I don't know, back in the day, it was Apache rewrite rules in every layer between everything that passed through a web server, and there was rewrite rules there or logic there. And that's a lot to unpack as you're trying to move to new technologies, right? So
for sure.
Anyways, cool.
We're gonna skip 3 here for a second because that's what I want to show off in just a little bit. I wanted to jump down here to where was this I found interesting, which I honestly was I was surprised to see it in this report, where the Fargate usage is growing a lot over the past, since this was 2019 till 2020. Seeing that 1 in 3 of the container environments uses Fargates is fascinating, because that's the AWS. If you don't want to run EC2 instances, you want compute, you just want the container to run somewhere and have it fully managed. Fargate is that solution that we provide, and seeing that grow at a Datadog observe, what Datadog observes, and seeing that trend continue with your customers is really cool to me.
Yeah, Fargate's been a fun one because we got to work with AWS engineering team ahead of the initial Fargate launch, and one of my favorite reInvent memories is getting a text message from a product manager at AWS saying you can flip the Fargate demo on just as the keynote ended, and just seeing every dude in the massive Datadog booth, just seeing every screen switch over to show Fargate demos and graphs. That was a lot of fun. But it's been what's been exciting is just seeing how much it grows, and I think it's pervasive. Even whether your customers are using ECS or EKS or running their own Kubernetes clusters or running Docker on their hosts that they manage, almost everybody has this some amount of Fargate in their environment. We also see a huge correlation between that and true, with people doing serverless workloads via Lambda. It's just not everything fits in a Lambda function, and so sometimes you have to run compute in a container, and Fargate makes that easy, because if you don't have any of the tools and the organizational knowledge around managing hosts on a day-to-day basis, why bring another host into the picture? Just throw some containers out there. So it's folks are. I think what we're seeing customers is love the efficiency of only paying for what they use, and they really like the fact that there's just less management overhead for them. So it's seeing ton of growth.
Yeah, and I'll tell you, I mean, this just speaks to the gravity of serverless, and as customers, as engineers, developers, they're building and iterating. They want to do less as much as they can. They want to focus less on the undifferentiated heavy lifting, right? Managing your instances and having to rotate them, patch them. It's a lot of work. And I think what you're seeing is, from this graph is it was below 10%. Now it's over 30%. People are finding use cases where they can offload from EC2 instances or virtual machines and move that workload to Fargate. And that's incredible growth.
This one I found interesting as far as the larger the cluster size, basically. Zoom, right? Yeah. The larger the cluster size, the bigger the node type is. And I find that really interesting because sometimes you would think like, oh, well, you have, 1,000 instances in your cluster. Oh, they must all be small. It's like, no. As you get to a certain level, like where you have constraints tends to be like, I can't put enough containers on something. So let me grow that, that instance size. And orchestrating a smaller number of instances is typically easier, but might have a larger blast radius, right? If I run my Kubernetes cluster that has one giant, instance, and it has, you can't run 100, you could run 100 containers on one, 1,000 containers on one or something. Like
Kubernetes on the mainframe.
Right. If that goes down, like that has a big blast radius of like my application now feels that impact. And so seeing that shift is cool.
Yeah, there's a balance there. I think this also sort of fits in with the, with the fact we'll talk about later around resource utilization and sort of how efficient folks are being with their deployments. But I think Kubernetes has all these different angles of scale, right? When I talk to customers all the time, or it's like they say, well, what's the most what's the largest, what's the most complex container workload you've seen? It's like, well, okay, there's all these different axes. Like, are you talking about number of namespaces? Are we talking about number of nodes? Are we talking about number of pods? How about number of containers per pod? And like all of these different knobs have different impacts on how you scale your cluster and how you run your cluster. And so if you look at somebody like OpenAI, who writes all these amazing blog posts about how they run their ML workloads on Kubernetes, you run that cluster very differently than if you're Datadog running a bunch of stateful workloads on, for collecting metrics from all of our customers, or if you're a entirely stateless web app that all you have to do is auto scale up the containers when there's more web traffic coming in. So it just how you approach this manage really depends on the type of traffic you're getting and the type of workloads. But yeah, I think people just like, less nodes means less complexity, right? So and in theory, you can bin pack that and get more efficiencies, right?
Right.
So.
And at some point, more cores, maybe your jobs require more cores. So it's like, even if I have 16 cores, maybe that's still one container. But if that's, or maybe that's a bunch of little ones, but then you start hitting different limits of like, okay, open file limits on the server, IPs per instance, all of those sorts of things become considerations as you try to really pack things into one.
Right. And I think I remember some stories out of the, out of AWS recent, from AWS, right, around some of the work you all were doing with Kinesis back in November, December. And one of the things was like, it's not just throw more compute at it, it's all of the other things downstream of that compute in terms of how it impacts your application and your settings, right? I think I saw some posts from you about that at some point, Justin, I think too.
And people are having some feedback in the comments too, as far as like, we've had lots of discussions about how to drive that cost down for customers, whether that is like Fargate spots. We did a show a little while ago for managed spot instances. So if you're using EKS and you have managed nodes, you can just flip the switch to say, hey, make these spots. And we want, to gain some benefits and costs there. We might need more instances, but with Kubernetes does add value of like, hey, if there's a little bit of churn here, or if these things need to drain, that's okay. Like we can actually hopefully gracefully sort of roll those through. I don't know if I expected this one or not. The top daemon sets are typically, a CNI of some point. I mean, I know
Yep.
in Kubernetes, like that is very like deploy your CNI, your network interface with daemon sets, and just every node gets it and it does all that sort of work. I see a lot of other daemon sets too, which I was surprised not to see, like image pre-pullers or some sort of like infrastructure setup sort of thing. Or I mean, I'm assuming like the Datadog
to be
agent's not
clear,
here.
Yeah, so I mean, we try not to report on ourselves because if the data's here, it likely came from the Datadog agent. So it'd be like 100% of users.
100% of our users.
100% of Datadog users use Datadog. It's like, okay, thanks. This particular graph, though, focused. I mean, the thing is, we did slice this down to things that do routing or networking or consensus building as we were looking at daemon sets. I think there were other technologies we saw, but I thought we thought this was we thought this was like a more an interesting slice to just show how folks are dealing with that, with all of that cross container, cross pod, cross host connectivity. And so this has been interesting. And there's another stat later on, I believe, around specific software technologies that we see, and I think that probably aligns a little bit closer with what you've seen in terms of what you would expect. Yeah. But I'll note things like Nginx show up in both, and I think that's just diverse. Like people use Nginx in so many different ways these days. It's not just the web server you use for static files anymore, right? They're using it for service meshes. They're using it for reverse proxies. They're using it for load balancing. Like there's lots of places where Nginx fits in, and they seem to have done well for themselves in the container world.
Yeah, it's right. Like seeing this report, like when I see the Nginx there as the third, my immediate thought is, okay, people are running a daemon set and they publish port 80, port 443, and they put that behind their load balancer as the ingress controller. So every node can accept traffic from that ingress.
Yep.
And running ingress as a daemon set is a great way just to like, hey, completely fault tolerant around all my nodes. I have a load balancer in front of it, and it can hit every instance if it wants to. Which
I think is probably a different use case than when just like a lot of people have Nginx in all of their pods as like as one of the many containers, right?
Right. Which is also funny because I don't tend to see Istio here as a daemon, like, or is that Istio or Envoy?
In this particular case, it's an Istio. It would be container images that contain Istio, but I would imagine Envoy's in there as Envoy's in there as well, right? So
right, because that could still like that piece could still be doing the same sort of thing of Nginx, but just being Istio for ingress in clusters and saying, hey, I don't necessarily need the service mesh, but I do want Istio or Envoy to control my north-south or in and out traffic for my cluster. So
I mean, and I think that's all of these technologies have such a myriad of use cases that like you have to, from this graph, I can't, it's hard for me to tell you what the specific use case for Istio is. What I can tell you is I see lots of Istio container images, which is a different, would be a different set of graphs and reports on the usage of them. So,
and I would love to see like year over year, sort of like this graph, like what did this look like last year and the year before? Because some of those things maybe have drastically changed over time.
So I think in this graph, this is the first time we're reporting on this graph specifically. I think if we went down to fact number 11, down at 11, that's where you start to see. I think this one's shifted a little bit more over time.
Let me skip to that. Oh, well, let me point out one thing on this last one. Kubernetes version.
Yeah.
It's hard to upgrade Kubernetes. Like that's not even like that's something that's not easy. If people missed in the stream, EKS landed 119 support yesterday or the day before, 2 days ago.
Right.
So EKS now has 119, but it's still like you can see these sort of cliffs of 115 to 116. 116 had API deprecations that were hard to migrate from, and like, hey, we have to actually do work to migrate some of these workloads. So a lot of people will find that cluster they've migrated a lot of things, and then Kubernetes releases are 3 times a year. And so keeping up with that is a job to not only make sure the cluster itself is healthy, but also all the workloads remain healthy.
And I mean, we don't show it on the graph here because it's an increasingly small audience, but I have customers still running Kubernetes, 1.3. And they're like, they expect us, as a vendor to support them, whether it's 1.3 or 1.19 or 1. Or the beta coming out in a few, weeks of like, what is it, 121, right? So, I I think this is, this for me is more of a reminder to, the Kubernetes development audience and to the vendors that live around this ecosystem of, hey, you can't always just assume that everybody's on the latest version because they're not. There's this long tail of upgrades that takes a while to hit.
Right.
And we've seen, talk about this, about saying, hey, I need that latest bleeding edge version. And you see, realistically, while it's great to have and you want to test and move to that version, there's work to be done to get there. And it's not always a day one, thing to just easily migrate. So it's interesting to see that.
Service mesh adoption. That was.
We kind of hinted at it earlier.
Yeah. The registry adoption was interesting. Seeing people cloud provider registries and third-party registries makes up what you're seeing as half of all registry, like where the polls are coming from. So that's kind of cool to see. It is, people, whatever the use case would be. Like I always used to throw everything on Docker Hub, and now it's like, well, a lot of companies have registries now. Like, Quay was nice for a while. GitHub has a registry. ECR Public is now available. Which also I was going to mention. I just saw. Was it also 2 days ago? ECR Public has poll numbers now for like how often images are pulled. So it's sorted by polls. And Datadog Agent was right up there near the top.
That's I did not realize that was there. I'll have to go check out the stats. That's exciting.
Yeah, no, it shows up on the registry now, so you can see how many times it's been pulled.
I think it's there's so many registries are becoming such a just like hopefully you're not pulling all of your gems and your wheels from the public repos and doing some sort of curation and management of your images there internally. Like I would hope you're doing the same thing with your containers, even if it is just the vanilla Istio container. But at the end of the, it's been interesting to see this trend. And this graph is from before. I think ECR, when this graph came out, I think ECR Public had been out for a day or was about to come out in a few days, right? So this is pre the GitHub and ECR and a few of the other registries that have popped up lately. So this is one I want to keep a close eye on for when we do this report again in 2021. Yeah. Because I'm guessing that rather than being 3 bars, you'll see way more diversity here.
Yeah. The popular images was cool to see. Not what I would have expected actually initially. Like Nginx. See, I pull Nginx all the time for demos, and Redis is pretty popular. But like actually seeing Postgres and Elasticsearch and MySQL, like the next 3 of stateful applications as the top technologies, like that's kind of fascinating to me. Yeah, I mean, when this was the thing that surprised me from the very first report we ran, which was the number of data stores and stateful workloads that show up in usage, and which ones, right? Like Redis is, has long been a leader. Nginx seems to always be in first place. It's been that way for probably 4 or 5 years now. The ones that showed up here this year more than in the past has been CI providers like GitLab and Jenkins, which was I think goes back to what we were saying earlier, which is lots of folks are containers are a much more efficient and much more sort of repeatable way in which to run all of your CI/CD workloads. So are those specifically the runners? I'm assuming that's not GitLab, like the actual hosting service, but the runners for CI. I believe so. Like I have to go back and look at the data, but that's my assumption is that that would make sense. These are the runners, right? Yeah. Like you might have the orchestrators themselves running in containers too, but that's not going to result in 20% adoption here. So
right.
Yeah. And Vault sneaking in there at the end was also really cool. Like I didn't realize how many people were using Vault from containers, and HashiCorp team's been doing a great job like making that usable on lots of different orchestrators and saying like, hey, Vault was originally like you had this isolated VM that was secure that only certain things could access, and now like a lot of those like boundary constraints have moved into the orchestrators with network policies and RBAC and that sort of stuff. So it's like, hey, we can actually secure it running in these sort of shared contexts as well. Yeah, and I love how HashiCorp has done such a great job of integrating with everything, across
everything across the cloud native ecosystem. It's not like Vault will only work well with Nomad and and their technologies and console right all together. Like you have to use this whole stack together. They built this very composable ecosystem where you can pick the things that make sense for your workloads and across all the different runners. So
yeah,
I do think the these stateful services. I know there's a chart below that is specific to stateful workloads, but I mean it speaks to the community. And when you see Postgres, Elasticsearch, MySQL. A few years ago, like this was a no-go. Like running a database in containers, like you're crazy. But I mean, it tells you how far the community's gone in building this out. Even Kafka being on here, running Kafka is not easy, but because of the community building, Helm charts around this to make it just really simple to get up and running with these stateful services, it just speaks to how much power is there now.
I'll put one shout out for the Datadog data engineering team that runs their Kafka on top of Kubernetes. They did a great talk about this that's up on the Datadog engineering blog. If you look for like Datadog and Kafka Kit, which is an open source project we put out for scaling up and scaling down and managing our Kafka clusters, like that runs all on top of Kubernetes and is they've done a great job with that. So
that's cool. Is that also like a Kubernetes operator, or is that is that the fundamental like scaling shards and stuff?
It's sort of it's for scaling. It's for both. They do all of this for scaling Kafka itself, but also for it also includes tools for like remapping where things across shards and across topics.
Oh, cool.
So it's a whole distribution of tools. So
awesome.
I'll drop a link in the chat.
Super cool.
So the last one that I wanted to go back and address was, I think it was point 3. Yeah, here we go. So workloads in clusters that are not using the correct requests, CPU or memory, is a big problem because people wildly guess at like, I think I need this much. Like, I think this needs a gig of RAM and a CPU, right? Because like people either way overestimate or underestimate because people just aren't good at like understanding what a computer's doing. Fundamentally. So I mean, I think what I like about this fact is everybody tells me the reason they're moving towards Kubernetes. One of the many reasons they're moving towards Kubernetes is that they want to be more efficient. They want to get more out of more compute for less dollars, and like they're going to bin pack and they're going to make everything's going to be perfectly sized. And then I look at a graph like this and it's like, no, I'm sorry. You're like, that's not where you're focused yet. Right now, you're focused on scale. You're focused on ease of deployment for engineers. You will eventually get to bin packing and efficiencies, but that is not a day one or probably even a year one outcome. It's further down the line.
And that's okay, right? That's okay. Yeah. Like I think this should be a goal. Don't expect on day one going into Kubernetes, going to ECS containers, that you're going to be perfectly utilizing all your EC2, your virtual machines, and you're just going to be amazing. It takes time. And I think you have to learn your patterns, understand your workloads, and then you right size. But don't just skip right sizing altogether. Otherwise, you're going to be on this graph as the company that's not utilizing any of your instances. So,
yeah.
So, and that gets me right to like the thing I wanted to actually show usage of was the vertical pod autoscaler, which is a open source project that runs in Kubernetes that helps with this, like how big should my pod be? Like I probably don't actually know. There's a couple different ways to tackle this. The VPA is one of them. Cube cost is another one that actually gives you like really good reports on, hey, if I care about the cost of my container clusters, how do I like actually use that? And so I just wanted to show a quick demo here of VPA in action to kind of see what it would look like for a user, because some people aren't using it. And some people are scared of it because it's not necessarily something that's like, oh, like I could just throw this in and everything's gonna be magic. Like, no, like you do need some setup and you need to make sure you're safe with how you use it. This graph scared me the first time I saw it. Because I'm not gonna lie, like, okay, there's a lot of moving parts here, and like, what did I just need to do? And like, not having any like numbers, steps of like, what's it doing? Like, it was hard. So the basics of it are you need a metric server inside your cluster, which most clusters should have at some level. you're going to have metrics. This gives you metrics on the pods and also on the nodes. A lot of other things will use this metric server. So it's not just for VPA. Horizontal pod autoscaler will use a metric server. I think even Carpenter, the AWS Kubernetes autoscaler, is using it as well. So a lot of things will probably need this section over here. So you probably already have it. The other side of that is this pod. Like what are you running? Which is also feeding these metrics into the metric server. And then you have the actual vertical pod autoscaler controller and an admission controller. And the admission controller will actually, like, when you submit a pod, change things for you. And so it says, oh, I see you requested a gig of RAM. All of my metrics show you don't actually need a gig of RAM. So I'm going to adjust that for you on submission so that by the time it lands in Kubernetes as a pod, it's already right-sized and based on historical data from what I've seen. You don't have to run it this way. This is an option. VPA has a couple different options on how you run it. So real quick here, I'll make that just one more bigger. I have a couple different services here. I have a Nginx over provision deployment where it's just an Nginx deployment. I have 3 replicas, and I told it I want a whole CPU and 1 gig of RAM for Nginx off the shelf. It is not going to use that. I could guarantee you right now. Like that's just not what's going to happen. And so if I look at get pods, I can see I already have it deployed here, right? I have these 2 services, Nginx. I have my 3 replicas. They're running, and kubernetes top. Let's look at what I'm actually using. Right, like I requested. You just saw the spec. I'm up here. I'm requesting like 1 whole CPU, and I'm using 0 of it. But like I'm a fraction of what I'm requesting here. So nothing that I actually require is being used here. And I'm using 2 megs of memory, and I said I wanted a gig. Right. So I am way over provisioned because I guessed at it, and that's where exactly the vertical pod autoscaler comes in. If I look at get pods in, I already deployed the VPA, so it has those pieces. It has the admission controller, which is that incoming webhook, the recommender, which actually like runs the rules to say like, hey, am I doing the right thing, and an updater that actually just like pulls in information from the metric server to kind of like, hey, where are we at? The very first thing you're actually going to need, you can have this run like sort of autopilot, but you need to make a vertical pod autoscaler, like a rule for it. And so I have that here. Nope. Cat. Next. This is what the rule looks like. And this is a little bit more advanced than what you actually need. But I'm saying here, I want you to automatically adjust my pods. If you see that metrics don't line up with what I'm using, please just go ahead and replace them. Like I don't need to do it on webhook. I don't need to do it like it. Actually, I believe this will do the webhook too, but it also replaces pods in place. So I can say, hey, I have 3 of them running. Are they right? Yes or no? If not, please replace them for me. I'm saying what I'm targeting here. I'm targeting that Nginx deployment, nothing else. It's not going to look at anything else and like say, oh, I'm going to resize everything now. It's just like, okay, any of those pods, and even based on container name. So I could say like, oh, based on this deployment, which container in the pod? Because if I have a pod that has 3 containers in it, I only want to look at one of them maybe. And so this will actually fine-grain tune into which container in a deployment and pod do you want to actually right size. And then here I'm just saying minimum I want, maximum I want, and my what to control, CPU or memory. So that's the fundamentals. You don't need all of this. If I look at the default, they give you a demo. Here's like a similar one, which takes out the policy, and I thought one other piece. Anyway, they have this hamster service that the hamster service that they provide with VPA will scale up because the initial deployment is actually too small. And if I look at that top, I can see it's using half a core, but it requested less than that, so it's going to resize it the other way. But I'm going to look at the slimming it down right now. So all I really need to do, I have the components running, I have the metric server, I have the VPA installed, and I have a pod that is not correctly sized. So if I deploy that, It's a rule. It's a config map, essentially. I mean, it's a CRD that gets deployed. The autoscaler will look at it and then start comparing things and say, "Hey, is this correct?" And we'll slowly start to see as the VPA says, "Oh, that one's not using the right the right stats. I'm going to go ahead and scale that down and redeploy it." And so it will start replacing pods one at a time based on my rule set and say, "Hey, there it goes. Hey, this is actually wrong. We don't want this to be, this size. Don't do that." So as it's spinning up again, there's my next one. And which one was that? Let's see. This guy or girl. I don't know. Pods aren't gendered. Get. I can see in the YAML spec here where my requests are. Here we go. So it automatically put me down at that minimum, that 50 millicores of, okay, you didn't actually need a core. I know you requested the core, but you don't need it. So we're going to go ahead and pull that back down, and also bumped my memory back down to the low end of where I said my limits were. So I wanted to point this out as like, that report showed me like, wow, like this is still a lot of people are doing this with just static sort of requests. And VPA, horizontal pod autoscaler, will give you more of them if you need to scale up or down. VPA will actually replace those pods. You can't do it in place because the way the spec works, I mean, you technically can adjust the C group size, but Kubernetes doesn't do that. It's all about immutable objects that get stored and then run. And so as these pods get rolled out, each one of them will say, okay, the VPA is going to I'm going to scale this down as small as possible because you're not using it. And if I deploy another deployment and I say, oh, I want it to be big again, I can adjust VPA to say yes or no. Should I automatically scale this back down to what I've historically seen? So that was really like the only piece I wanted to show here is like this. It's pretty simple to run. It's a couple more pieces inside the cluster, and you can say what namespaces and what pods and deployments you should look at. So start small and say, oh, I have a feeling this deployment is probably scaled incorrectly. And there's my third pod, terminating, setting a new one, and rescaling it. So if I get all my pods again, I'll see all of them were, restarted in the last 2 minutes, which is when I started this demo, essentially. They were running a lot longer than that. So, and it goes the other way, where I say, oh, if all of a sudden I'm requesting more, VPA will step that up and say, hey, now you're requesting a lot. Let's go ahead and make this newer, a larger, request here. So we can get a little bit closer to that right sizing, and hopefully that Datadog report will start to get smaller number of pods that are drastically over or undersized.
That's awesome. Do you have any, I guess, recommendations as at what point does someone, do I introduce horizontal pod autoscaling and vertical pod autoscaler at the same time? Like how would you recommend someone approach that if they're just coming in, deploying their first service?
I mean, I think as Alon said, like be comfortable with it and don't just do everything at once, right? Like solve a business problem. And if you start saying, hey, like before you go to, I need to add 50 nodes to my cluster, because you also have the cluster autoscaler, which adds instances, right? Like there's all these dimensions of how you don't have control of the cluster anymore. You're trusting software systems to do all the things we used to tweak manually, whether that was like VMware or AWS changing instance size or whatever. Like all these VMs are like, oh, I need to tweak this. I need more memory. I need more CPU. You're trusting these controllers to do all that, but don't just dive into it, because you're going to have too many things to learn and too many things to debug. So one step at a time. If you think that you want to, get better utilization out of your existing instances, I would try VPA first. If you're seeing applications that are, hitting limits or they're like, oh, I'm getting timeouts on things, look at horizontal pod autoscaler to see okay, if it is a stateless application, I can scale more of these and handle more requests. So look at that business need and say, okay, what is it that I'm actually trying to do? And then figure out which piece you need. And at some point, a lot of people just dive in and I want cluster autoscaler. because I either want to scale up or scale down, because that's where money is. They see that cost month to month and say, oh, like I need this to be cheaper, so I'm going to use cluster autoscaler. But you might be able to get similar benefits out of VPA and say like, oh, let's just scale these containers down and I can actually fit more of them and I don't need more instances. I can bin pack a little better. And
I think that it all fits together, right, in interesting ways, right? Not every workload benefits from being sharded across multiple instances of that workload. So some of those workloads just need more memory, more CPU. In some cases, it's like if it's a like, single threaded app, like it's not exactly going to be able to, like you can throw all the memory and CPU you want at it. It's not going to let you process more requests. So then you do need to split it up in that, with HPA. And so I think VPA, I would say, though, is also a little bit younger than HPA and even younger. And HPA is younger than, the cluster auto scaling. So like each of these are at a different level of maturity. On the, what we see with a lot of Datadog customers is, is using HPA with Datadog metrics as well. So not just CPU and memory and like what's going on there, but like how much work is how much work is this queue doing? And you emit a metric about that queue into Datadog. That's been a pretty popular pattern as well.
Nice. Well said. Well said, both of you. Well, I think, is it time to wrap, Justin?
I think so.
A good show.
I think we covered a lot of good stuff and just kind of seeing and thanks everyone for joining, because there was a lot of good feedback and questions that came up. So it was good interaction and yeah.
Awesome. Well, thanks for having me on the show, Justin and Adam. It's fun to be on the couch, and hopefully we'll be back someday.
Please, I definitely think we could benefit, and I think our viewers would benefit from seeing Datadog in action on AWS. I'd love to show it. So thanks for joining.
Let's do it. Thanks, guys.
All right, thanks.
Cool. Have a good one. Thanks, everyone.